Perfect. All right. Got it. I'm live. Interesting. How do I share this? Share. Okay, so let's copy that. I'm live. Come make, see me. Oh wow, my entire Twitter timeline is visible. Great. I want to know, let's quit Slack. Okay. Oh, internet's going to be slow while I'm doing this. Generate graph images. Can I also add a video capture device? Okay. I don't know what I'm doing. Interesting. Hey. Okay. There we go. Look at that. Cool. And then I can like scale this down. Oh, look at that. I'll be down here. Wow, interesting. Okay. I don't even know if anybody's watching. Well, YouTube is saying my Wi-Fi sucks. They're probably very right. Okay. Well, that's okay. We'll try to figure this out together. I wanna fix my terminal settings. Let's make it cool. Okay. Well, okay. I'll just start doing stuff, and then maybe people will come on. So here's what I want to do. I want to make a program with Ink that can graph in 2D, basically. So let's say if I have a function that's like takes x and returns x times x, then I want this thing to output an image for me that is the graph of that thing. So I'm going to set, let's start with like width 50 by 50 pixels. And just to test, I'll just like log width times height. Okay, so what I really want to do if I can figure out how to use my terminal, is I want to write an image. So here's how writing an image in Ink works. So we make a file with the width and height. Start with like 3 by 3 just to keep it simple. And we're going to give it a list. And the list is going to have 4, 5, 6, 7, 8, 9. In this case, it's going to be a 3 by 3 image, and then I'm going to write graph.bmp, this file. When it's done, it should say done. If it errored, it should say error. Cool, so let's run that. Cool, so you can see it's tiny, but this is a 3 by 3 image, and I can show you that it is 3 by 3 because I can go in and say like change that to 0 and like change these values a little bit. And I can rerun it. And now we'll see a little bit more color. So this is how we make images in Ink programs. So cool, we have that. What I actually want to do though is I want to here somehow like make a graph. So I think the way I'm going to go about this is I'll make a white square that's all white pixels, and then for each like column of pixels, I'll mark the right point in this scale. So to do that, we need some kind of a scale. So I think we're going to do 100, which means that this is going to be like pixels per unit. So 100 pixels across will amount to like 1 unit of the graph. So first of all, we're going to make a big white square, or big white rectangle, I guess. So to do that, we're going to need some helper functions, range, map. And so the way that this is going to work is we'll have pixels which is going to be an array. So we're going to map the range of 0 to height, going up by 1. And for each row, we're going to return the result of mapping the range of 0 to width by 1. Then here we can do pixels. Save image. Okay. And then let's make this more like 50 by 50 just to see that everything works. What's happening? Oh, okay, so it expects, okay, here's what I'll do. I forgot how my functions worked. So we actually want this. So we want to go width times height. For all of the pixels, make white pixels, basically. And there's a syntax error because I left out a parenthesis. And now this is a white pixel that's 50 by 50. Okay, cool. We're off to a roaring start and nobody watching. It's good. Let me share a link somewhere. Oh, I know what to do. Cool, maybe we'll get some people. Okay, so we have our function. Let's put it closer down here. So this is the function to graph. Let's make it 2 times x, just to make it simple. Okay, so we need to basically, for each column, for each like value in width. So that's going to be for each value in, we're always going to start at 0 because it makes things easier. Maybe I'll change it later. But it's a good place to put this thing. Well, let's put it up here. 0 to, let's say, width. And we're going to so this is going to be the number of pixel, and we have to divide it by the scale. So this is the x value, and the actual x value that we put into the function is actually going to be this divided by scale. And we need to also be able to know if a value is in a y range. So given a y, it's in y range if it is greater than 0 and it's also less than height divided by scale. Is that right? I think that's right. Okay. So y is a function of x And then we need to find, so in pixels, y of x is going to be 0, 0, let's say like 250 instead. Except this isn't how we access it. This is actually going to be y times width plus x. Is that how that works? Okay, so for each position in the x-axis, this is definitely going to fail. Oh, didn't. What happened? Absolutely nothing happened. Oh, we got one dot there. That's interesting. Okay. Unclear why that's red either, because this is supposed to be a blue pixel. Okay, well, let's log this. So let's log so x maps to y, and then we'll make, let's just make this easier. So this is going to be 0, and this is going to be 1, and we'll give it x and y. Okay, so we got some values here. They look pretty correct, actually. So 0.2 goes to 0.4, 0.3 goes to 0.6. That seems mostly right. Okay. So then what is the value of y times? Oh, you know what? You know what's wrong? Is we have to scale these guys up. So scaled x is floor of x times scale, and then scaled y is going to be floor of y times scale. I bet this is going to work. Nothing still. Interesting. Okay, well, so this is supposed to be xy, and then y times width plus x. Oh, I mean, oh, you know why? It's because scaled x times scaled y. Didn't even use the variables I defined. Okay. See, now we have something, but it goes across twice. So for each width value, plots 2 points, and they're still not blue. I think I would know more if I just made all of them black. Okay. That's interesting. Oh, we did. Okay, so we only plot things if it's in y's range. So if scaled y, I don't think I'm actually going to use this guy. So if scaled y is greater than 0 and scaled y is less than height, then we're going to mark the pixels. Otherwise, it's going to like overflow, and I think that's why this happened. Cool, except this is 2x, so it should be a lot steeper. So I think what I'm going to be doing is flipping the axes accidentally. And yes, that is what I did. So this has to be y and this has to be x. And if I do that, and for the kick of it, let's also change this up so it's x times x divided by 2, which should be a nice curve. And now, oh, that's way too little of a curve. Okay, cool. Let's make it a little bigger. So let's make it like 300 by 300, and let's make it like, I don't know. Cool. There's a graph. Now, okay, this is kind of cool, but I think, okay, there we go. But this, how can we make this more interesting? So one way we could make it more interesting is if the line wasn't so thin. Like once you go to like 500 by 500, the lines are going to be just invisible. So one way to do that is to not just mark one pixel, but mark multiple pixels. So so we can mark one that's one above, or one below, sorry. I think that's going to work out better. And we can also mark things that are one below. So if we do this, this is actually going to be like, this is basically determining the thickness of the line. So now the line's a lot thicker, you can actually see it. And it's actually kind of nice. It would be nice if we could parameterize it, which would look like for each. So stroke, let's make it 2 for now. So in each, range from 0 to stroke 1, my indentation is not the most polished thing. Okay, so this is going to be our x offset, and this is going to be our y offset. So the way this is going to work is we're going to do scaled y minus y offset times width scaled x minus x offset. And we're going to mark that black. Cool, and in theory, that should give us the same graph. Excellent. Okay, I'm just going to get rid of these parentheses because that's a little easier to read. I want to make it so that I can do it for a bunch of functions and set their color. So here's what I'll do here. So I'll say functions. It's going to be a dictionary of, actually it's going to be a list of items that are like function is x to x times x divided by 2, and color is going to be 0, 0, 0. Sure, I think that should work. Now let's pick another one. It's going to be x 2 times the sine of x, and the color is going to be red, just for kicks. I don't know, 3 times the cosine. What's a good looking function? I don't know. 0, 0, 2, 5, 5. So that should be like a really strong blue. Cool, and then we're going to have to basically do this for each function inside here. So for each in functions, we're going to do this thing where the function is the item.f, and the color is the item.color. And then we'll just take and shove this entire thing in here. And 22. Oh, okay, that's not allowed. 38. Oh, yeah. Okay, so this is going to take a little more time, but hey, there we go. So that happened. Oh, I didn't use the color. So this is going to be color. And now they're colorful. Great. Let's make it like more like 500 by 500. And we'll make the stroke width like 4. And it's slow because it's slow, and I wasn't like being super efficient, but there. Now it's like a 5 by 5 square, and we have some of these graphs. I think it'd be cool if it was centered at 0. So, yikes. So let's try to do that. So right now I'm just getting, like, this is how I'm getting the place on the graph. If we want to actually, like, the x and y aren't actually based on, like, the x and y are the values. When we scale them, we have to also scale them and then offset them. So like, this is going to be minus the width times half, and then height. I think this might work. If we want to just center it at 0, then no, maybe not. Maybe these are just steps in the dark. I don't think this is right either. Okay, so let's think. Y times scale. Yeah, that's definitely not it. Okay, so what if x is like, if x is 0, then we actually want to add, no, this feels right, Like, this is the correct, oh, but you know what happened is we're not starting at 0 anymore. Like, this is, the x value is actually going to be also scaled up. Oh, that's not right either. Divided by scale. No, okay. So I think what we need to do is actually do this here. So plus minus width divided by 2. And while I'm doing that, I'm also going to think about maybe a way to optimize it. I didn't typo. Cool. Hey, there we go. Okay, so 0 is like right here. I want to make axis lines. So axis lines for, so x is going to be, they're both going to be like down the middle. So like mid x is just scale divided by 2. I mean height width divided by 2. Mid y is just height divided by 2. And for each thing in the width, I'm going to set pixels so for each thing, this pixel is a 1D array. So we need to start at, so this is for the, yeah. Oh yeah, so this is going to be only for every x offset. X times width. No. Yeah, so mid y times height times height. Oh yeah, no, this is right. No, mid times y width. It's because it's supposed to be like down here, this kind of stuff. Except we don't need offsets. So times width plus x. We're going to set that to be like 0, 0, 0, which is a 1 pixel wide line. And then the same thing with height, except this time it's going to be y, and then y times mid x is also going to be 0, 0, 0. Mid x is not defined. And if we do that, we should have like graph lines. Cool, look at that. Okay, that's kind of cool. Let's try a different width. So let's try like 600 by 400. Theoretically should be faster. Just to make sure that I'm not like making any assumptions about the shape of the canvas. Cool. So now it's graphing a little more stuff. Scale is 100. Yeah, that makes sense. This makes sense. Cool. I think it would be nice if we could know if they were like, it was marked off every one. Maybe that's not super useful. Oh yeah, that is useful. Okay, so instead of just marking the middles, we're going to mark the middles, and then we're going to mark like all the units, basically. So just occurred to me that I probably don't have audio on. Audio input capture. Is that? I can't tell. I think that's working. I'll listen back later. Maybe it'll work, maybe it won't. Okay. So instead of just those ones, so instead of just the axis lines, we want to also go through all the ones that are basically all the units offset from 0. So those are the zeros. So how do we do this efficiently? So we start at 0 for like the vertical unit lines. So for vertical unit lines, we start at 0, we go to like, start at 0 and we go up to whatever is the min of the scaled up half width. We do like plus and minus. So I think I'm going to abstract this out into, so draw horizontal axis is going to, we're going to give you some like, x value, x number, right? No, horizontal. So this is going to be y number. Let's do vertical first. Draw vertical axis. We're going to give you an x, and what you're going to do is for each range in zeroed width, mid y, draw vertical. Oh no, so this is actually for this, and this is for this. So cool. So when we're drawing the vertical axes, instead of just doing this for 0, which is basically what this does, or for mid x, we're just going to do it for all x's, and so I think it would be really useful to have the notion of like scaling to the canvas being the image dimensions, scaling to the canvas, and scaling to the graph coordinates. So like scale x to canvas is going to take an x, and it's going to x will be like a graph value, and we need to multiply it by the scale and then offset it. So it's kind of like what we did earlier down here. So here we so this is basically what we need to do. So multiply by the scale and offset it. So to scale x, we're just going to basically copy this, and then to scale y, scale y to canvas. We take the y, let me scale it there. To scale x to graph is going to do the inverse. So it's going to take a pixel, and it's going to x minus width divided by 2, and then divided by the scale. Does that sound right? Yeah, so I think at this point it'd be really useful to have the notion of like a half width, which is going to be width divided by 2, and then half height. It's going to be height divided by 2. Let's just abbreviate these. Yikes. Okay. So this is going to be half width, and this is going to be half height, and we're going to subtract half width, and to scale y to graph, we'll just do y minus half height divided by scale. Cool. So now we have that. We can really just say scaled x is going to be scale to canvas of x, and scaled y is going to be scale y to canvas of y. Are people watching? Hey, Amog! I don't know if you're still here, but please tell me that everything is working, because I feel like nothing is working. Okay, so if you missed it earlier, basically I'm trying to write a program that makes graphs that look like this, but I'm doing it in ink. So right now we can sort of make a graph based on centered and 0, and we can sort of make these lines happen, but I'm trying to make make it a little easier to work with, and also draw the vertical and horizontal axis lines at not just 0, but all of the units by 1 offsets. So yeah, that's what I'm doing. Item color. And we can do it in a few more places. So X here is scale to graph XPS. Ta-da! Okay, this is most definitely not gonna work. Yeah, scale wide canvas is not fine. Did I misspell it? I misspelled it! Okay. So if everything goes well, this should still work the same way Easter. I just moved some variables around. Except for the axes won't be there. So yeah. So we have a more general way of drawing the axes now though. So for when we're drawing all the vertical axes, this is what we do. And the same with horizontal. So X here is going to be the value. We want it here to be so we want this to be the scale X to canvas version of X from the graph, and we want this to be scale Y to canvas version of Y. And what am I doing? X, yeah. So let's start with it to convert axis 0. Cool. So Hey, okay. It's a little redundant, so I'll make these start at 1, and I'll do separately vertical axis at 0, horizontal axis at 0, and I'll also give it the color. So I want these things to be able to take X in a color, and a Y in a color, and these will just be the color that I gave it. The reason I'm going to do that is because the zeros to be black. I want these to be like 80, 80, 80. Much fainter. That doesn't really make that much of a difference, did it? It is fainter, but it doesn't make that much of a difference. How about we define gray as 50, 150. We replace all with gray. Excellent. Well, to be even fainter, go like 220. Oh yeah, that's closer. Stuff closer. I think you could play with 3 for stroke width. Yeah, that's not that bad. I think that's pretty good. No, this is easier to read. I think I like that better. 76. Cool. Still working. So, one weird thing is there's a little bit of a bleed here because it's like the 0 rounds down or something. this scale x to graph rounds down to 0. This is a hack, but if x is less than 0, we're going to make it 0. Otherwise, we get x. Avoid x leading past 0. And yeah, seems pretty good. Let's add one more function. X comma x3 is 2 minus x times x. I'm going to make this 1 times 2 times minus 0.4 1.5. This color is going to be this is not defined. I'll just take this out. Oh, I know. So tall. Okay. Let's make it 600. And scale it down a little. Cool, look at that. Come on, better colors. That'll do. This one could be like 20. This is blue. Could be more like purple. This is red. Red can be like yeah. Green, still green. It's 2. Oh. It's It could be. Right. No. Alright, that's pretty good. Canvas. Name. Name sign. Name sign. Name cubic. Oh, that's not correct. Log finish rendering functions. And then up here we can say during axes. So canvas and functions. Uh-huh. I don't really use the raw language, so I can just do cool, and that should still be the same. Alright. This is pretty cool. I think I'll call it a day. Hello. Well, that was fun. Bye.